Hello, my dear students. Welcome to a new episode of Science. Today we will talk about compounds and chemical changes. You have probably sprinkled table salt on food to change its taste. Yes, for sure, we all use salt. Did you know that table salt is made from a poisonous gas and a metal that explodes in water? The two elements, sodium metal and the chlorine gas, are combined. In a flash of heat and light, the sodium and the chlorine gas are changed. Only bits of table salt remain. As you can see in this GIF, this is the reaction of sodium metal and the chlorine gas. Then only bits of table salt remain. Table salt is called sodium chloride. Table salt is called sodium chloride. Why are the properties of sodium chloride so different from the properties of the sodium metal and the chlorine gas? Because sodium chloride forms from sodium and the chlorine atoms. The joining of the atoms is what gives the sodium chloride new and different properties. Because sodium chloride is a compound, and the compounds have different properties than the elements that made them. A compound is formed by the combination of two or more elements. A compound is formed by the combination of two or more elements. Compounds have properties different from their individual elements, as we saw it from the sodium chloride. This is the formation of a compound. As you can see, sodium, which is a soft reactive metal that explodes on contact with water. Can you imagine this? And the chlorine also, it's a poisonous yellow-green gas. Putting sodium in chlorine causes a fiery reaction. Then the reaction produces sodium chloride, which is the table salt that we use. Then we come to the names and formulas. Have you ever left a metal spoon out in the rain and come back later to find it's covered with rust? This is an example of rust. Rust is a compound formed when iron in the spoon combines with oxygen in the air. All compounds have chemical names and many have common names as well. The chemical names indicate which elements make up the compound. The chemical name for rust is iron oxide. The chemical name for rust, as example, this is iron oxide. Chemical names use the names of elements. Often the second element has the last part of its name changed slightly. You can see this change in the iron oxide and the sodium chloride. The last part of the second element is changed slightly. Sometimes we use prefixes, some parts that are put before the word or the term to indicate the number of atoms in a compound. For example, we use mon for meaning one, like monoxide. Also di or bi meaning two, like dioxide, and tri for three, like trioxide, for example. Carbon dioxide is a gas with one carbon atom for every two oxygen atoms. Here, this is dioxide, two oxygen atoms. Compounds have chemical formulas, just like the elements you have learned about. Yes, for sure, but the compounds have more than one elemental symbol because they are made from more than one kind of element. Yes, for sure. For example, the chemical formula of iron oxide is Fe2O3. This formula tells us that two iron atoms combine with three oxygen atoms to form the molecule or the compound of iron oxide. As you can see, two iron atoms combines with three oxygen atoms to form iron oxide. To form a fructose, for example, or the fruit sugar, it's named fructose. 6 carbon atoms, 12 hydrogen atoms, and the 6 oxygen atoms, they must combine together. As you can see, these are the 6 carbon atoms. They are linked to also 6 oxygen atoms. The gray ones and the blue ones are the 12 hydrogen atoms. This is the molecule of, or the compound of fructose, or the fruit sugar. What are the chemical changes? Suppose that you spilled vinegar with its strong, sharp odor. What a smell, right? How could you get rid of it? If you mixed vinegar with water, you could still smell it. If you froze vinegar, also it would still be vinegar, just in a solid form. As long as you are making physical changes, the vinegar will always be vinegar, but you need to make a chemical change. To remove the vinegar, you have to change it chemically. Chemical changes occur when atoms link together in new ways to create substances different from the original substances. So we will make a chemical change to the vinegar to produce a different substance. This is also known as chemical reaction. For example, if you combine baking soda with vinegar, a chemical change occurs. Once you pour the vinegar to the baking soda, bubbles will form. Let's see. If you combine baking soda with vinegar, a chemical change occurs. The baking soda changes and bubbles form. Look here, the vinegar in the cup. Then the man started to put the baking soda. Look at the bubbles. The bubbles are new substance, as you can see. Also, a new white solid is left behind. This is a product. The new substances that formed have different properties than both the vinegar and baking soda. The bubbles are a gas, and the white solid does not react with the vinegar. During a chemical reaction, atoms in the baking soda and vinegar link together in new ways, and this reaction forms sodium acetate. This is named sodium acetate. Water and the carbon dioxide. For sure, the bubbles from the reaction are carbon dioxide, and the white solid is sodium acetate. As you can see, this is the equation of the reaction. We have the acetic acid C2H4O2 and the sodium bicarbonate. This is the baking soda, NaHCO3. So it gives the sodium acetate NaC2H3O2 and the water H2O plus the bubbles of carbon dioxide CO2. Then what about the chemical equations? In studying math, you probably have seen the equations 2 plus 6 equal 8 or 3 plus 7 equals 6 plus 4. Yes, both of them, this side is 10 and the other side also equals 10. Chemists write equations for chemical changes similar to math equations. For example, hydrogen gas and oxygen gas combine to form water. A chemical equation keeps a track of which substances are used and in what ratio. The number in front of the chemical formula, we already studied the chemical formula. The number in front of the chemical formula tells how many of those molecules are used in the chemical reaction. The chemicals on the left side of a chemical equation are called reactants. To the left side, they are called reactants. For example, X plus Y, these are the reactants. The chemicals on the right side of the chemical equation are called products. So this is XY, these are the products. For the water forming reaction, as we talked before, the reactants are hydrogen and oxygen, and the product is water. The equation reads, as you can see here, 2 hydrogen molecules plus 1 oxygen molecule make 2 water molecules. The reactants and the products of the chemical reaction may be in different states of matter. Yes, the hydrogen and the oxygen are gases, while water is a liquid. In a math equation, the left side must equal to the right side. How does the left side of a chemical equation compare to the right side? Let's see. The total mass of the reactants equals the total mass of the products in a chemical reaction. This is known as the law of conservation of mass. This is how mass is conserved or saved. In other words, the total number of each type of atom must be the same in the reactants and the products. For the water-forming reaction, the number of hydrogen and oxygen atoms are the same on both sides of the equation. As you can see, this is hydrogen molecule and oxygen molecule equal water molecules, but we have H2O. This is 2 atoms of hydrogen. So in this case, 2 atoms of hydrogen, and here we have 2 atoms of hydrogen. Okay, but Oxygen here, two oxygen atoms. This is a molecule. And here we have only one oxygen atom. So we must put number 2 here to become the oxygen, two atoms in the products and two atoms in the reactants. But in this case, the hydrogen here, it became four atoms. So we put also two before the hydrogen molecule. So let's count again the number of hydrogen atoms here in the reactants. 2 times 2 equal 4. And in the products, 2 times 2 equal also 4. Okay, this is okay for the hydrogen. What about the oxygen? We have here two oxygen atoms. And on the other side, 2 times 1, that is beside the O of water, equals 2. So also two oxygen atoms in the product. So this is the conservation of mass, or the number of each atom. Each type of atom in the reactants is equal to the number of each type of atom in the products. Math equations make sense whether you read them from right to left or from left to right. Chemical equations are similar. Yes, most chemical changes are reversible. They can be undone. They can be reversed backward. When a chemical reaction is reversed, the products break apart or combine to form the original reactants. When a chemical reaction is reversed, the products break apart or combine to form the original reactants again. Water, for example, can be broken down into hydrogen and oxygen gas. How can you spot a chemical change? Chemical changes produce new substances. Yes, the substances have different properties than the previous ones. Often you can see, hear, or even smell the formation of new substances as a chemical change occurs. A change in color is one sign of a chemical reaction, as you can see on this shirt. When bleach whitens a piece of cloth, it does so by chemically changing dyes on the cloth or change the cloth itself. It changes the dyes or the colors of the cloth or even the cloth itself. Chemical changes form layers on metals and often dull their color. So we are talking about rust, yes. For example, rust is reddish while the iron that the rust forms from is shiny. Can you see the difference in color? When metals corrode, corrosion is due to a chemical change. Yes, for sure. When corrosion of a metal causes a color change, this is called tarnish. Tarnish. So when corrosion takes place and it changes the color of the metal, this is called tarnish. Also, when you place an antacid tablet in water, these are the medicines that are effervescent. A chemical reaction occurs and bubbles form, as you can see. The chemical reaction takes place and the bubbles start to form. The appearance of bubbles is another sign that a chemical change has occurred. The appearance of bubbles is another sign that chemical change has occurred. Do you remember when we mixed baking soda and vinegar? They are mixed. Bubbles of carbon dioxide show that a chemical change takes place there too. So these are three signs of chemical change. The change in color, when bleach removes the color from clothing by means of a chemical change. Tarnish, the silver in this spoon reacts with oxygen or sulfur to form a tarnish. Also releases gases as the antacid reacts with water, bubbles of carbon dioxide form. Let's move on. Chemical changes can produce more than just gases. A precipitate is a solid formed from the chemical reaction of some solutions. A precipitate is a solid formed from chemical reactions of some solutions. Like what? When a sink is not cleaned, it may develop a sticky white layer. It's called soap scum. Soap scum. This sticky white layer that forms in the sink, it's a precipitate formed from solutions of soap and water as well. Some chemical changes involve the release of light and heat. Yes, for example, the burning candle. This is a chemical reaction, produces a hot flame. The heat and light come from the combination of atoms in the candle and its wick with oxygen from the air. Wick is the fuse or the cord, the one in the middle part of the candle that you light. If a chemical reaction releases energy, then reversing the same chemical reaction will absorb energy. Yes, for sure. And here are the other forms of chemical change: the precipitate and releasing energy. The precipitate, as you can see, when two solutions form a precipitate, a chemical change has occurred. Also, a release of energy, as light or heat can indicate a chemical change. How do we use the chemical changes? Chemical reactions are taking place all the time. These chemical reactions allow the living things, even us, to carry out our life functions and processes. For example, do you remember photosynthesis? It requires the energy from the sun to help create simple sugars in plants. Plants and animals both use cellular respiration to release energy from food. Yes, both plants and animals use this energy to fuel their cells. Also, we can use the chemical changes in other ways to get energy. Machines can also use the energy from chemical reactions. A space shuttle, for example, needs a huge amount of energy to fly into space. In the space shuttle's main engines, hydrogen and oxygen molecules chemically react and release hot gases to push the shuttle upward, as you can see. The product from this chemical reaction is totally safe to the environment. It is just water. They are mixing hydrogen and oxygen molecules to chemically react and release the hot gases. Chemical reactions also are the only way to form the compounds that we were talking about in the beginning. Some compounds, such as fossil fuels, are formed in nature, but other compounds are artificial or are made by man, like plastics, for example. There is almost an infinite variety of useful compounds that can be made through chemical changes. And here we came to the end of our episode. I hope you understood this part. Thank you guys and goodbye.